Welcome friends, let us continue to study air compressor on my YouTube channel. Kindly like, share and subscribe my YouTube channel. In today's lecture, we are going to study about the construction and working of positive displacement compressor, and particularly we are going to study single stage reciprocating compressor considering clearance. So, single stage, single acting, reciprocating compressor considering clearance. Considering clearance means it is assumed that when piston is at TDC, or you can say at the extreme left condition in the horizontal engine, there is some gap between piston and cylinder head. So you can see in the animation, when piston is extremely at left condition, there is some gap. And due to that gap, it is considered that this reciprocating compressor has clearance. Generally, the clearance gap is provided to accommodate the valve opening and to prevent the, you can say, collision between the piston and the cylinder head. So, all engines have some clearance volume or clearance gap. Working. This is the cylinder, this is the piston which moves from your left hand side to right hand side. And right hand side to left hand side. But it not reaches to the cylinder head, so there is some gap, and this due to that it is said that it is the reciprocating compressor with considering clearance. Let us draw the PV diagram. This is the PV diagram. Let us start when piston is at extremely right condition at point number 1. And at point number 1, suction valve close. At point number 1, suction valve close, and due to that it moves from your right hand side to left hand side, and whatever the air available on the left hand side of the piston, it is compressed. So it is a point number, process number 1 to 2. There is a compression process. Here it can be any of the process, maybe polytropic process, maybe isothermal process, maybe adiabatic process. So let us see, consider here it is a 1 to 2 is a process. At point number 2, discharge valve opens. As the discharge valve opens, high pressure air is transferred to the storage tank. Again, piston continues to move from your right hand side to left hand side. And point number 3, discharge valve close. But here, point number 3 is not on the y-axis because piston is not touching or reaches to the cylinder. There is always some gap. So, point number 3 is not at the y-axis. So, at point number 3, discharge valve close. Now, piston should move from your left hand side to right hand side, and during that time, the suction valve should open. Now, but what happens actually? As the discharge valve has closed, piston is at left hand side, some air is here or entrapped into the cylinder. And what is the pressure of air? Pressure of air is very high pressure, that is P2 pressure. High pressure air is inside the cylinder. Now when piston tries to move, or piston is moving from your left hand side to right hand side, even if the suction valve opens, do you think that the air from the atmosphere will enter? No, because atmospheric air is at atmospheric pressure, but the pressure inside the cylinder is high pressure. So valve will also not open, and air from the atmosphere will not enter. Only what will happen? Whatever the high pressure air is here, it will be expanded. It means its pressure will decrease, and it will pass through the process number 3 to 4, which is known as the expansion process. And at point number 4, the pressure of air has reduced to the atmospheric pressure, and due to that, actually the suction valve opens at point number 4, not at point number 3. Because at point number 3, pressure of the air inside the cylinder is very high, and therefore the suction valve will not open at point number 3, it will open at point number 4. Now the piston moves from your left hand side to right hand side, and air from the atmosphere is entered between the point number 4 and point number 1. Actually, it should enter between the point number 3 and point number 1, but actually it enters between the point number 4 and point number 1 at pressure P1, that is the atmospheric pressure. So this is the PV diagram for single stage, single acting reciprocating compressor considering clearance. One suction valve close, 1-2 compression process, 2 discharge valve open, 1-2 compression process, 3 discharge valve close, 3 actually or ideally suction valve should open, but it will not open because at point number 3 whatever the air is available, it is having high pressure, and due to that suction valve will not open. Ideally it should open at point number 3. Piston is moving from your left hand side to right hand side. Whatever the air inside the cylinder is there, it is expanded. It means its pressure is reduced, and when its pressure reaches to the P4, that is the atmospheric pressure, at that time actually or practically the suction valve opens and air starts entering, and that is the air entry, point number 4 to point number 1. Now the working stroke. Initially electric motor is switched on. Now as the electric motor starts, crankshaft rotates and piston reciprocates. Due to the gap, when piston is at TDC, gap is filled up with some air. Now piston moves from TDC to BDC. Due to the movement of piston, air present inside the cylinder expands first, and then low vacuum is generated inside the cylinder. So at point number 3, right, piston starts moving from your left hand side to right hand side if it is horizontal engine, and if it is vertical engine, top dead center to bottom dead center, right? But as the pressure is high, right, initially the pressure or air will be expanded and it reaches to the low pressure, that is the atmospheric pressure or the vacuum, and then the suction valve opens. Thus the inlet valve opens and air from the atmosphere enters into the cylinder. The less quantity of air enters inside the cylinder as compared to the case without considering clearance. So if we consider that there is no clearance, without considering clearance, then what will happen? At point number 3 here on XY diagram, or that is on Y axis, the suction valve will open and continuously it will enter air up to the point number 1. But actually due to the considering clearance, air is entered between the point number 4 and point number 1. Second stroke. During second stroke, piston moves from your BDC to TDC, that is bottom dead center to top dead center in vertical engine, and this is horizontal, so we can say it is from right hand side to left hand side. Due to the movement of the piston, gap between the piston and cylinder head decreases, and thus the pressure of air inside the cylinder increases. As the pressure of air increases, discharge valve opens and compressed air enters into the storage tank. When piston reaches to the TDC, due to the gap, some air remains inside the cylinder. In storage tank, compressed air is stored and whenever necessary it is utilized. For this case also, ideal process of air compression is isothermal process. So air can be compressed using any of the process, that is the isothermal process or adiabatic process or the polytropic process. But ideal is isothermal because the work required to drive the compressor is less. So that is the thing, but you can say PV diagram. Here it can be 122, it may be polytropic, 122 days, it may be isothermal, it can be adiabatic. So it can be like that. Now let us see. 122 is a compression process. So let us find out the volume at each point. This is V3 point. This is known as the clearance volume because piston never moves left hand side to point number 3. So that is known as the clearance volume, VC. This is V1. That is the total volume of the cylinder. So we can say that swept volume of the cylinder is V1 minus V3, and this volume is known as the swept volume of the cylinder because piston moves from your left hand side from point number 3 to point number 1. So it is the swept volume. Suction valve open, theoretically air should start entering, means at point number 3, that is V3, suction valve should open and theoretically air should start entering from this position, and suction valve closed theoretically and air should stop entering. So it should start entering from this point and it should stop entering from this point. And so theoretically air entry is equal to swept volume is equal to V1 minus V3. But practically air starts entering from point number 4, that is V4 here, and it's practically air stops entering at point number 1. So practically air entry is equal to effective swept volume is equal to V1 minus V4. That is known as the effective swept volume, means practically air during that region only air is entered. So Vs actual swept volume is V1 minus V3 and effective swept volume is V1 minus V4. Effective swept volume is V1 minus V4. Actual work required to drive the compressor, and that area is 1, 2, 3, 4, 1. That is the actual area to drive the or work required to drive the compressor. And it can be found out by using that equation, area between 12561 minus area of 35643. Volumetric efficiency. Ratio of free air delivered to displacement of compressor. It is also known as the ratio of effective swept volume to swept volume. And therefore, volumetric efficiency is equals to effective swept volume divided by swept volume. Effective swept volume means practically what percentage or what air enters, and swept volume means theoretically air entry. Here in this case, effective swept volume is V1 minus V4 and theoretically it is V1 minus V3. So that is V1 minus V4 divided by V1 minus V3 is known as the volumetric efficiency. And volumetric efficiency for this case is always less than 1. Generally it is in the range of 60 to 80%. Kindly ask your queries in the comment box of the video. Kindly like, share and subscribe my YouTube channel. Thank you.